Find n and x bar. What is n?
Sample size.
N is your sample size. By the way, have you noticed that little lowercase n is used in a sample, and if you have a population, it's an uppercase n? Capital N? And x bar is?
Mean.
Sample mean, yep. Find the z sub c. And over here on the hints, I'm going to write draw a bell curve. Use a z-table. Step 4 is to find the margin of error.
So it's not always going to be 95%?
No. Usually it's 80, 90, 95, or 99. They're also in the bottom corner of this, but this bottom corner, do you see how it says 95? The level of confidence is 1.96. These are usually the ones that are being used, but I really recommend that you remind yourself how to find this, because in the AP test, this will not be there. And they often will do something sneaky, like they'll be like 76% confident, so they know that you have to figure it out instead of just having it memorized. So don't rely on that corner, but it is there. E equals z sub c times sigma divided by the square root of n. Formula we just learned. Next is to make your confidence interval. This looks like a TIE fighter. In the middle is x bar, and this side is x bar plus that error, and this side is x bar minus the error. And the last step is to state your answer in context. I know that especially Gustavo is going to hate this because it means he has to write a sentence on every single problem, which obviously is a nightmare. But your problem will always say something like this: I am blank confident, as in like 90% confident, 99% confident, whatever, that the population mean is between blank and blank. And I know that you're thinking, but Ms. Nussbaum, why would we have to write that every time? Because you already know, you can see our confidence interval, you know, and that's because on the AP test, if it's on a free response question, they always, and honestly, in free response, there's almost always one hypothesis test question, and there's almost always one of these confidence intervals, and they always want it in context, and that's always part of the grade. So I'm just trying to train you to always do it, and that way on the AP test you'll do it. Yep.
So what would you say for example 2 for that?
Well, we haven't finished example 2, but if we had done example 2, I would have said that it was, so example 2, what the thing was 2.45 hours. So I would have said, I would have added 2.45 to this and subtracted 2.45 to this. And then said, I'm 90% confident that the average number, the population average of hours that a grocery store employee works is between this time and this time. And it would have been that number plus or minus that 2.45.
So you use the same percent?
Yes.
Okay.
Yep.
That's what I was gonna ask. How do you figure out the percent you are confident?
It says in the problem. It says with a 95% confidence. See how it said in this problem, use a 95% level of confidence? That is not like a, there's, if there ever, I think 95 or 90 is pretty standard to use, but it's really rare that they'd ever give a free response question without telling you the level of confidence. Usually they tell you exactly what they want. If they don't say, use 90 or 95, but almost, I mean, I've never seen one where they haven't said it. All right, next up. A college admission director wishes to estimate the mean ages of all students currently enrolled. In a random sample of 20 students, the mean is found to be 22.9 years. From past studies, the standard deviation is known to be 1.5 years. So that's a population standard deviation because they've already done a study before. And the population is normal. So step one, I have to verify that that is known. Yes. It's normal. Yes. And how many people did they ask?
20.
Ooh, they only asked 20. So in this problem, we would, just making sure I didn't make a mistake. Why did they do this? Population is normally distributed. Oh, or. Okay, we need to change this. Normal or. Do you guys remember how the central limit theorem says that if your n is big enough, then it becomes normal anyway? So it's either normal already or n is greater than or equal to 30. Either one's an okay thing. Sorry, my mistake. Okay, so we've got it normal, so we're already good to go. All right, so next step, step number 2. N is 20 and x bar is 22.9. Find the margin of error. All right, so E equals, remind me, I know that there's a little corner part of your paper that tells you exactly what it is for 90%. But let's say 90% was in the middle. There'd be 5% on either side. So what should we look up in the table? 0.05 in the middle of the table. Everybody look up 0.05 in the middle of the table. Do you see how one spot is 0.0495 and one spot is 0.0505? So this is an instant where we're going to do 1.645. This is positive 1.645. This is negative 1.645. If you actually look back at the homework assignments we've done before, every time they did one where they were exactly splitting it was one of these percentages that constantly comes up. Times 1.5 divided by the square root of 20. Okay, so put that in your calculator. I got E equals do you get 0.55? Am I wrong? I must be. 1.645. Yeah, I got that. Okay.
Yeah.
You got 0.55? Tegan.
So what's the z sub c?
This is the z sub c. Those z scores that are on the edge of 90% confident. But they only use the positive one.
Is subscript only used to label stuff?
Yes. This is basically anytime you see a subscript, that is more specificity. Like when it's the mean of means, it's the x bar of the x bars. Or this is a z-score for our confidence interval. That's why it's called z sub c, because it's a z-score for our confidence interval. Yep.
Would you ever use it as negative?
Well, you kind of do, because when you're making this thing right here, so let's do it together. Put the x bar in the middle, which is 22.9. And then I'm going to add, so 22.9 plus 0.55 on the upper end, and I'm going to subtract 0.55 on the lower end. So to answer your question, this one would have been a negative z-score, adding in a negative z-score, and this would be adding in